G'day Internet, Andrew Russell here for my third development video for my game that I'm making. Today's video I'm going to talk about the networking. Let's watch it. Okay, so to begin with I've got a very simple server. I'll start time running. If you see this number jumping around during the video, it means I've stuffed up my dialogue and have had to splice the video together. So, a very simple server. We've basically got some characters that I can move around. So, it's basically a really cut down version of the game. Now, I'm going to stop time and I'm going to add some clients. You can see each of these clients is a network client, has a certain amount of lag. Now I should point out that this lag is actually double the number you see there. That's the one-way flight time in milliseconds. So the lag that you traditionally display in a game would be 500 milliseconds for each of the first three clients, and then 2 whole seconds for the last one, and then followed by a packet loss. So the first client loses 0% of the packets, the next one loses 10% and 20%. So I'm going to display packets and I'm going to start time going, label them. So the first packet you see flying up from the clients is the connection packet. I'll speed up a little more. That'll hit the server and the server will respond with a snapshot of the current world state, which will then appear on each client. Now the packets that I'm sending are reliable unordered, so I'm using Lidgren as my underlying network library, or at least I will be. What I'm running on now is sort of a dummy implementation that lets me display all the packets as they fly across my fake network. So every packet will eventually arrive at the client, but they will arrive. Some packets will arrive late or out of order. So basically each packet is a change in the world state. So if I move this character over to the end and I speed time back up again, I'll slow it right down again, you can see that the delta packets are making their way across the network. So each of those deltas represents a change in the data of that particular character. So what the clients do, because it's possible for packets to arrive late or out of order, they keep a buffer that you can see here that shows when the packets arrive. They get put into this buffer in their tick order. So there's 20 ticks per second, in case you're wondering. So you can see there's holes in the buffer of incoming deltas, and basically when the client receives when the client misses a delta, when it doesn't arrive in time, what the client will just do is guess what that delta should be until that delta finally arrives. So basically what happens when a packet gets dropped is that the client guesses, and when that packet eventually arrives, the client will rewind time all the way back to the start of that buffer and play through all of the deltas that it's received and guess any more holes that appear to update the present state of the world to a more accurate representation of what's on the server. So I'll speed that up again and demonstrate what that looks like. So I've got a button here that will force packets to be dropped. Again, they're not so much dropped as they just arrive late. So this will make a packet arrive much, much later than it should. So I'll slow down time a bit more so you can see this. So I'm going to start the cat girl off moving, and then I'm going to hold down my button now. That's going to cause a whole lot of deltas to come out of the server and be really slow. So this is only dropping important packets, is the way I've set this up. So you can see all those deltas coming out of the server are really very slow. And you can see that the buffer is being built up here in each of the clients and is going behind the present time. So you can see that the present time is in fact everything from between the 5 and the 6 block essentially is exactly the point of the present time, and everything to the left of it is in the past, and so any incoming changes will actually alter the present. Anything to the right of that center line is actually in the future according to the client's view of the world, so it's essentially a buffer. So that gives packets that get dropped a chance to arrive before the present time happens. It's all very complicated. So before the present time happens, so they won't cause any sort of glitching when they do arrive. So ideally, the client will extend that buffer out in front as long as it needs to, and you can see on the side all of these slight variations in how fast the client is ticking time. Those are to make sure it stays on time with the server, and also to make sure it keeps its buffer at the target length to try and avoid having the past change too much. So I showed you what happened when the client drops packets and has to predict what they would contain. And you see it does a pretty good job. You can actually see what I'm going to show you on the failing client at the bottom, because it dropped the starting packet. So what happens when I drop the starting packet? The client doesn't have enough information to create an accurate prediction. So I'm going to hold down my button that makes it drop packets and start her moving. So those deltas coming in are the moving packets, and you'll see that the clients have to sort of essentially run to catch up. This is called smoothing, and so I can actually hit a key to show you what I like to call ghosts of what is happening in the underlying smoothing algorithm. So I'm going to do that again, and I'm going to move her to spot 2 and drop the packets for her starting to move. When they eventually come in, you can see that you can see in blue the position where she's supposed to be, and in red is the position where she is, which will slowly catch up to the blue position to cancel out that difference in the present state, because the past, according to the client, has changed. It's a wibbly-wobbly, timey-wimey thing. So one more time I'll show you this, and you can see that she catches up. And of course then you can add, you can spawn characters on the server and they appear on the clients, and then you can, let's get rid of the princess one here, delete. And so yeah, you can spawn and delete characters from the server onto the clients. What I still have to do is work on having the clients inform the server of the movement. So at the moment all the movements are happening on the server and being sent to the clients. I want to have the clients sending movements to the server, which is obviously required for them to actually play the game rather than just sort of replay it. And so that's what I'm working on at the moment. So that was a look at my networking code. Hopefully next week I'll be able to show you that working in the game itself, but we'll see how we go. If you'd like to see more of these videos, subscribe to me on YouTube, or subscribe to my blog at andrewrussell.net, or follow me on Twitter at _AndrewRussell. And I'll see you next week.